Alright, here goes a video on the difference between big arc and little arc. This is inverse trig. So what we're going to do is we're actually going to find theta with given values. So to first introduce you to what a sine wave looks like, I want you to think about the unit circle that you already are familiar with. So when you stretch a sine wave out onto an xy coordinate plane, it's no longer a unit circle that goes around and around in circles. So the way this works is your x-axis is actually your theta, and your y-axis is actually the value for the sine of that angle measure. So let's start. Let's start at 0. So at 0 degrees, sine equals 0. So at 0 degrees, sine is equal to 0. So then what's going to happen is you're going to start drawing an angle. And we can imagine that this is like a 30-degree angle. So at 30 degrees, or as we know, pi over 6, what is your y value here? Well, y at 30 degrees is actually 1/2. So at 30 degrees, or pi over 6, you're at 1/2. And as you can see, this is going to continue to go up until you get to pi over 2, where you get a maximum height of 1. So this is what the beginning of a sine wave looks like. But notice that x does not become negative. The x value is actually your theta, your angle. So once you get further along the way, this angle right here would be, say, 150 degrees, or 5 pi over 6. But look what's happening to your y value. Your y value is getting smaller as you approach all the way back down till you get to 0 once you are at pi radians. So what's going to happen after that? Well, in a unit circle, you start going backwards. You stay on the circle, but when you stretch it out graphically, it's going to continue forever and ever and ever. So once you get all the way down to 3 pi over 2, your y value for sine is actually a -1, which is why you're down here. But now watch what happens again. As you continue, as you approach 2 pi, or 360 degrees, your y value is getting higher again as you go all the way back up to 0. And then what's going to happen after that? Well, on a unit circle, you start rotating again, and you start your angles of rotation, so that exact same pattern is going to start to repeat itself after you get to 2 pi. And the other cool thing about this is if you were to go negative, a negative angle of rotation, you would just go negative in the opposite direction, and that exact same wave is going to continue. The only thing we did is we took a sine of theta on a unit circle and stretch it linearly, because on a unit circle 360 degrees looks the exact same as 720 degrees. But if you were to stretch it out on a line, 720 degrees would be way out here, also known as 4 pi. So that's where these values are going to come from. So let's see what an inverse sine looks like. So to think about an inverse, remember, inverse means we switch x and y. So if we think on a unit circle, what is the sine of 30 degrees? The sine of 30 degrees, we have already said, is 1/2. But what else? What other angle also has a sine value of 1/2? Well, that would be 150 degrees, all the way over here. That's also 1/2, because these coordinates are positive for your y values. But also think about it this way. If we did our 30-degree angle plus another 360, 390 degrees also has the exact same 1/2 value. So if we were to think about it stretched out linearly, here's a 1/2. Look at how many values. It's just going to continue over and over and over. So this value right here at sine is equal to 1/2 is going to repeat itself 360 degrees, or 2 pi, later. And then this other one that we mentioned, 150 degrees, that's going to be here, and it's going to repeat itself again in another 2 pi, or 360 degrees later. So this is basically saying that pi, or sine, is going to repeat itself every 2 pi. The cycle will continue again, as you can see that I have graphed here in red. So, inverse switches x and y. So if we were to just switch this and switch our x and y and have an inverse, we are no longer going to have a function, okay, because the original does not pass the horizontal line test. So this is actually what our inverse sine looks like. And of course we can continue in the negative direction as well, just like we did in the original. So all we did here is flip x and y, which means your x-axis is now the sine theta and the y-axis is now your theta. So this is basically just working backwards, which means if I give you a sine of theta, you can actually go back and find what that angle measure is. And that's what today's lesson is about. So, arc sine. Arc sine is another name for sine to the negative 1. Okay, so inverse sine could be theta is equal to negative 1, or sine to the negative 1, which means inverse sine of y. But this can also be said as arc sine of y. So arc sine will have multiple answers. We just got done talking about that the sine of 30 is the same value as the sine of 150. So how do we get those answers? Well, your first answer is going to come directly from your calculator. But the second answer must be another positive angle using your reference angles. Okay? Now, as I also mentioned on the graph, this graph is going to repeat itself every 2 pi or 360 degrees. So our general solutions, there are infinitely many solutions to arc sine. So what we're going to need to do here is make sure we state it all. So let's do an example and you'll see what I'm talking about. So to find arc sine of the square root of 2 over 2 in degrees, we're going to do this example in degrees. And then once we switch to cosine, we'll switch to radians, so that way you know how to do both. The first value comes with your calculator. So with your calculator, all you have to do is type the second button, and that will bring up inverse sine, and then you're just going to type the square root of 2 divided by 2 in the calculator, and you are going to get, press enter, you'll get 45. And of course, make sure your calculator is in degrees. So your first value is 45 degrees. So let me sketch this out for you really quick, and I highly recommend that you do this because it will be valuable when you're getting into a whole bunch of mixes of sine, cosines, and tangent. So we get a 45 degree angle. That is our first one. So where else is sine positive? Sine is also positive in quadrant 2. That's when y is positive. So what other angle can we have? Well, this right here is 45 degrees. So you just have to repeat your 45 degrees as a reference angle in that quadrant. But this angle is not 45 degrees. You need to give a positive angle. So this is 45 degrees less than 180, so your other angle is 135 degrees. Okay? So now we just have to make sure we write our final answer. Since we are in degrees, the arc sine of the square root of 2 over 2, theta, is equal to 45 degrees plus 360k, and it's also equal to 135 degrees plus 360k. Now the 360k takes care of your angles of rotation. So you're going to have your 45, you're going to have your 405, and you're going to keep on adding 360, and if k is negative, it's going to go backwards. So we can also have negative 315 degrees because that would just be k of negative 1. So this is how you write your final answer. When you have a lowercase arc sine, or even if it's written like this, lowercase sine -1 of the square root of 2 over 2. That means you are listing your general solutions. So there's going to be an infinite number of solutions you can have. Okay? So now, very similar, but easier actually, is arcsine with a capital letter, also known as big sine -1. When you have a capital letter, it is only asking for the principal solution, just your calculator answer. And that's because we're going to make this sign a function. So if we go back to inverse, let's look at our inverse graph. Our inverse graph is obviously not a function. It does not pass the vertical line test. So how can we make it pass the vertical line test? Well, that's when you just use just a portion of the graph where you have no repeats, and that would be from this coordinate to that coordinate, because it must include 0, or the origin. So this blue section is what you would consider big arcsine. Just the blue section, because if you look at just the blue section, it does pass the vertical line test. So big arcsine, you will only have an answer between -90 and 90, or -π/2 and π/2 for your principal value. So all you have to do is take your graphing calculator and you press second sine of 0.5, and you are going to get an answer of 30 degrees. That's it. You are done. No plus 360K, no finding another angle. A capital letter is less work. You just use the calculator. It is just the principal value. All right? So that's it on the difference between big arc and little arc. So now what we're going to do is we're just going to do another example so you can see using cosine. But the math part is the exact same. So let's take a quick look at cosine. Remember, cosine, now we're still going to be using theta. So we're going to have our 0 degree or our 0 radian angle. But look at what happens. Cosine, as you know, is an x value. So at 0 degrees or 0 radians, you're already starting up here at the top at 1. And then look what happens. As you go backwards, and let's go all the way to our first tick mark, π/2, you have had your x value. The x value has gotten smaller. And then look, now your x value actually becomes negative, because now we're just looking at the x. We're not looking at the 0 here. This is pi, or 180 degrees. So as you can see, the x value is going to continue to get smaller until you get to -1. Now it can't get any smaller. Look what's happening now. Now it's going to get bigger again. So we're going to get bigger again for our x value. Okay, but that's, of course, the y value of this graph is actually the cosine of theta. So the cosine of 3π/2 is 0. That's why you're back at 0. And, of course, that is going to repeat itself again every time we get to 2π. And just like with sine, this is going to continue. So now you get into your angles of rotation. So right here you are now at, this would be an example of 5π/2, or if you're thinking about it in degrees, that's going to be 450 degrees, and it's just going to continue over and over and over. And of course, just like sine, you can go in the negative direction as well, because there's all just going to be on a unit circle. We just stretch the unit circle out on an xy coordinate plane. So, think about it again. Now, for cosine, this is going to start over here. We're still switching our x and y values. So this is just going to look very similar, except for now, again, inverse cosine or arc cosine is not a function again. It is not a function. So we are going to have to state multiple values, just like we did in the other one. So let's think about the cosine of 60. Just think about the cosine of 60. The cosine of 60 degrees, again, is 1/2. So at 60 degrees for cosine, we're going to have to go all the way out to 60 degrees, we're now at 1/2 again. And also think about it again. Cosine is when x is going to be your positive values. And of course you're going to see it's just again going to repeat itself. Even negative, it can be negative as well. So when you have an infinite number of values, just like little sine and little arc sine, little cosine is going to have multiple answers. So this one says find inverse cosine, little inverse cosine of the square root of 3/2 in radians. So you're going to use your calculator. You're just going to press second cosine of the square root of 3 divided by 2. And you're going to get your initial value of 30 degrees. However, I said in radians. So you have to divide by 180 degrees and change it to a fraction. And you're going to end up with pi over 6. So your first value is pi over 6. Now remember, this is when cosine has a positive square root of 3/2. So that is your pi over 6. Now where else is cosine going to be positive? Well, x is positive right here. So this has a pi over 6 reference angle. So this also has a pi over 6 reference angle. However, remember what I said earlier. The second value must be a positive angle. So you can say pi over 6 plus 2 pi k, but you cannot say negative pi over 6 plus 2 pi k. Negative pi over 6, your second one's always positive. So what else can you do? Well, you can just, this is a full 2 pi rotation, so pi over 6 away from there is 11 pi over 6 plus 2 pi k. Remember, your second one must be positive. Okay? Now, arc cosine is the same thing. It's only your calculator. Now, this one is going to go from 0 to 180, though, or 0 to pi. And that's because, let's look again, it must include 0. So we're starting here, and we are not allowed to have repeats. So this will make it a function. So there is your arc cos. Okay? So, same thing with this. You just use your calculator. Second cosine of negative square root of 3 all over 2, and that is just going to give you the one answer that you need, except for it's going to give it to you in degrees in this situation. It's going to tell you that it's 150 degrees. Remember, we are in radians for this problem, so once you get your 150 degrees, just divide it by 180, math bracket, and you will get 5 pi over 6. That's it, done. No more answers for a big cos. Okay? So we're just about done here with the topics. I know this video is getting a little long, but that's because there's a lot of information to give you. Tangent. Remember tangent. Tangent is sine divided by cosine. So if you think about this graphically, at 0 degrees, tangent is 0 divided by 1, which is 0. But then, as it gets bigger, what happens when you get here? 1 divided by 0 is undefined. So you're going to have vertical asymptotes at every pi over 2. So we have 5 pi over 2, 3 pi over 2. And this is actually what it's going to grow and fall as you go backwards over and over and over again. Once you get to pi, it's 0 over 1, so pi is 0 again. But this is what it's going to look like. So notice what happens. This graph repeats itself every pi and not every 2 pi. So that makes answering these questions easier because let's think about it. If tangent is positive right here, this is where tangent's equal to 1. It also is right over here, 180 degrees away, because this is negative divided by a negative. This is positive divided by a positive. Tangent is negative in quadrants 2 and 4. So, since they're only 180 degrees away, or pi away, all you have to do is add or subtract 180k or pi k. So, when you're answering little arctan, Little arctan, you just need to find, again, the calculator value. So you take your calculator and you're going to type, and we'll answer this one in degrees. All you have to do is type second tangent of the square root of 3, and it's just going to give you 60 degrees. And all you have to do is add 180k. And then, of course, big inverse tangent of 1, use your calculator, you get 45 degrees. That's it, done. Do not add anything to it. And again, that's because this repeats every pi, or 180 degrees. And if you think about it on a graph, okay, the square root of 3, that's right about here. And in tangent land, that's 60 degrees away from here. But you do not, all it is 180 degrees more. Okay, so you do not need to find two things for tangent, only one. All right, so that covers everything. Now, I would like you to try 6 questions on your own. I would like you to find the values in radians, and then I have some for you to find to the nearest minute. Now, notice, radians are usually pretty nice, so it works out to a nice fraction. But when we talk about degrees, we can have all sorts of stuff. So, what I would like you to do first is think in radian terms and answer the first 3 questions. Just practice using the, big arc versus little arc, being able to draw out and see where it's going to be, and see how you do with this. All right? Pause it, try it, click play when you're ready. So let's see if you got these correct. The first one said arc sine. And it's a little arc, so you're going to have to do the general values here, which means infinite solutions. Now it said in radians, so you just had to use your calculator and you type negative pi, or the arc sine or inverse sine of negative root 2 over 2, and you're going to get negative 45. However, in radians, so you have to divide by 180, math bracket, and you're going to get a negative pi over 4. So that is your first one, your calculator answer. Okay, so the first one is allowed to be negative. But then your second one must be positive. So think about where sine is negative. Your y values are negative in quadrants 3 and 4. So how do you get this one? Well, you have to go pi over 4 away from this positive pi. So pi plus 1/4 pi is 5 pi over 4 plus 2 pi k. The second one, this is big tangent, so all you had to do is use your calculator and you just press second tangent of 0 and you get 0. That's it, you're done. There's nothing else to do. You don't even need to sketch to see where it was graphed. And for number 3, remember cosine is positive where x is positive. So it's going to be quadrant 1 and quadrant 4. So the first one, you just press some buttons in the calculator and you're going to end up getting 60 degrees, which is pi over 3, and of course plus your 2 pi k. So you have to do pi over 3, but it needs to be pi over 3 away from here. So all you needed to do was 2 pi minus pi over 3, and that's going to give you 5 pi over 3 plus your 2 pi k, because your second angle must be positive. Okay? So that's it for radians. Now, when you're in degrees, we're going to round to the nearest minute, which means you're going to be using your calculator, so they do not have to be nice, pretty angle numbers. So go right ahead and try these 3 on your own, and after that, I'll step you through it, and then we will be done with this lesson. So give them a try on your own. So how did you do on the last 3? Arctan, so remember we're going to have multiple answers, but tangent only needs 1. So you're just going to type this in the calculator, change it to degrees, minutes, and seconds, and round to the nearest minute of negative 80 degrees and 2 minutes. So that's right here. And then all you have to do is add 180k, because the other time tangent is negative is right across from it in the other quadrant. So that's 180 degrees. No need for 2 answers. Just don't forget your 180k. Number 5, all you had to do is use your calculator to get 47 degrees in 15 minutes. That's it. You're done, because it is a big cosine. Number 6, you had to use inverse sine, and you used the calculator to get 14 degrees in 17 minutes, of course, plus 360k. Now, how did you get the other one? Well, remember, you need to have a positive angle. So since this is a reference angle of 14 degrees and 17 minutes, it's 14 degrees and 17 minutes away from 180. So you just do 180 minus 14 degrees, 17 minutes in the calculator. You get 165 degrees and 43 minutes plus 360K, and that's it. You are done. So the biggest thing for today is basically knowing the difference between big arc and little arc and knowing how to find second angles. But otherwise, your calculator does most of the work for you. All right, this is Longo, and I'm out. See you, bye.